Hello, everyone. Good morning. Welcome back to the FAA webinar series. My name is Hatem Mashaki. I'm the solution architect for the FAA and your technical point of contact at Red Hat. In today's demo, we'll walk you through deploying a real world application in both development and testing environment in two multiple different cloud environments. So before I start, in each organizations, multiple teams and disciplines are involved in delivering an application. Frequently, there are many different point tools that might be used in any given process, and it's common to run into manual processes, procedures, and differing standards. And all of those make it difficult to ensure security, predictability, and best practices outcome. So, using a well-integrated automation framework across all those disciplines will ensure a reduction in IT costs, faster time to a market, greater security, and higher resiliency, as well as more innovation. So we will spend far less time on friction between the different teams and eliminating manual sources of errors and misconfiguration. So that's what automation can bring to the IT teams and organizations. So before I start, I would like to tell you a story, a small story of a customer of mine. It can be any FAA customers because I see this example applied to many FAA programs that I work with. So a year ago, before presenting this demo to that customer, they had a similar they have a similar setup of what we're going to see today. They are internal multi-tenant providers that provide uh, curated and hardened virtual machines from their VMware cloud, from their own VMware private cloud to their internal tenants. So, and I see this example within the FAA. The process itself, it used to take them weeks to onboard the new tenants or respond to any change, to any change request or any request from their tenants. So what happened? We work with this tenant. We presented to them what you're going to see today, and after they applied what we have today, a demo, they started on board and responding to those tenants within hours because they streamlined their entire process into a single pipeline. And what I'm going to focus today, something called a workflow. So it was a very successful change for them. They reduced their operational tasks and became more productive, and they're now much faster going to their market. Right. So now let's get into the weed and see things in action. So what are we gonna see today? I'm going to explore how you can create an automation CI/CD type pipeline that deploys infrastructure across multiple cloud environments, hardens an operating system and workloads to ensure security and compliance, and deploy an application in a mixed Linux and Windows multi-cloud environments. So I'm going ahead and log into my Ansible automation platform controller. So the automation platform controller is the main component of Ansible automation platform 2.0 and onwards. I'll use my admin. So I need an admin privilege to see everything in that controller. I'll use my credential in here. So what do you see in here? This is the automation controller platform. It's called the controller, is the engine for Ansible automation platform, where you would be onboarding your automation, defining the automation pipelines for various scenarios. Today, we will look at deploying applications across multiple cloud environments with patching, security, and application deployments. All of those steps we will do today, a manual by clicking one button, would also to be typically fully automated or triggered from your existing example. For example, your service now, or you could consume it as a catalog item, or from your Jenkins as a pipeline, or from or through a GitOps platform like calling automation controllers rich API. So one of the most powerful feature here or thing with automation controller is that allows you to not only onboard your automation, your projects and customization, but also this would be a platform where all your team would come in and consume automation to ensure the standards, that best practices, collaboration, and secure access to those projects across the board. So if you see in this example, I'm logging to the controller, and you are presented now with a dashboard view. And then depending on your role access, you would be consuming, viewing, or creating automation. So it could be your line of business coming here, or it could be your admin, or it could be an automation creator coming here to defining automation project. You can give access to different teams via our back row. So for instance, I see in here 2 hosts, 3 inventories, 3 projects. If I log in by my user, that uh, I might only see 1 project, 1 host, or 1 inventory. That depends on the roles that I'm using. So in this dashboard, I'll see multiple tabs. And the first thing we will explore together is the resources tab. And from the resources tabs, I'm going to navigate to templates. And there are 2 types of templates in here that you can work with. There is something called job template, and there is a workflow template. I'm gonna filter by workflow template, and this is what I'm going to focus today. And think about workflow templates as an automation pipelines. So it is multiple process, multiple step of a process, multiple jobs, multiple automation jobs are linked together. It might be linked together through approvals or through multiple steps or through notifications or events, things like that. So I have one here. It's called deploy app on a pre-prod AWS. And this is my workflow that I'm going to use today. I'm going to press on this workflow. And if you look in here, we'll see multiple tabs. You'll see the details. In the details, you'll see the job type. It's a workflow template, the name of it, when it was created, when was it modified. You'll see the variables that you're passing to this workflow. You see who's accessing this workflow. Only I have the admin, for instance, because everything works and based on RBAC. Let's say you have a user and this user is not assigned to this workflow, you would not be able to see him there, or he himself cannot log into this workflow. Notifications, schedules, all of them are blank now because we did not run this workflow yet. And the schedules, you can schedule what time this workflow to run, or you could have it like a batch job, or you could have it as a cron job, schedule based on daily basis or monthly or hourly. It depends on your need. I'm coming here to the most important tab, which is the visualizer. I will spend much time on this page. So now we're presented with a graphical outline of your automation pipeline. All these stages represent an actual piece of automation. So this is an actual piece of automations where it says job template, JT. You can also include a workflow template inside this workflow template. It should be denoted with WT. But I don't have any workflow inside this workflow. All of these one piece of automation, but I can have multiple pieces of automation similar to this inside a single job template. And in this particular case, we're consuming in here as a consumer of this automation, perhaps testing it end to end. In reality, for each of these different kind of pillars, for example, if you're doing infrastructure, it's common that you would have infrastructure team onboarding those capabilities, use secure collections and content that's available via the subscription of the Ansible automation platform. And after the infrastructure team has been deployed, you'd be the following team who's coming next. And here we have our infrastructure part, which is the first thing, creating infrastructure on AWS, and then creating infrastructure on Azure. After that, which means creating VPCs, subnets, preparing the landing zone, all of that will be automated. After we create this step, we move to the next step, which is creating the virtual machines themselves. You'll see the Windows VMs, real VMs, and on both Azure and AWS. So after that, we bring the other team who's coming to the next step to ensure compliance for the OS environment. For example, patching Linux and Windows nodes. So you can have those teams onboarding those capabilities and best practices, and they can have their own release cycles. So if you also think about it, like you have a different version releases, like a software development project. So you can bring automation project into Ansible automation platform controller. So you can have different versions releases associated with it. For instance, a Windows team can come and create Windows hardening playbooks and automation. And they can test this end to end with a given scenario with the different application types while ensuring compatibility with other layers before releasing this to new patch capability to the whole organization that you work with or the team that can come in and test the overall pipeline end to end from A to Z. So to see what's going on, what's behavior, what list changes. Let's say in case of patches, for example, it could be a new hot fix or a policy change. So you want to do CIS benchmark or you want to do a STIG compliance check. All of that you could do it in here within a piece of job that can run as a job template within your pipeline. End up doing it, all of it in one step, which is the patching, well, patching or Windows patching on AWS. So those are typically security and compliance policies that you can apply. For instance, both Linux and Windows, as those compliance change or tweak, you can test them end to end and release them as a new update. And then who's ever consuming this in a production, for instance, or pre-production will consume the latest approved standards seamlessly and transparently. So we're working here multiple teams on the same pipeline. Each has its own step. We can have multiple workflows for each team, integrate them together, take them into approvals. So let's say the infrastructure team created the infra, then the operation team comes here and they patch the operating system, and then we'll see the application team comes and deploy their application. So all of that will come together as a one team or as a couple of teams to gathered as a one team to create to complete a certain job. So of course this would be we've been working on the same platform, so you can test this end to end. You can share credentials across the board, so you don't have to give a credential or giving to your team or worry about managing those credentials. So you can onboard those credentials either to the platform itself, where we can, I'll show you that in a moment, or those credentials can be in a third party application. So for instance, CyberArk or HashiCorp Vault. And we integrate HashiCorp or CyberArk or other tools to Ansible automation and platform to fetch these credentials and communicate securely with your vault without exposing anything to the team or seeing it as a plain text. So where all of these credentials would be pulled, managed, and as part of your automation pipeline in full motion. So what I'm going to do now is going to exit this visualizer mode, and I'm going to launch this job that we have. And just to recap, what we're going to do now, we're going to create an infrastructure on both Azure and AWS. Then we'll create our virtual machines. We'll have 6 virtual machines. After that, we'll harden and patch these machines and then pass them to the application team to install their Podman and their web servers on those virtual machines. So coming in here, if you look at here, we have the launch button, and pressing on this launch button, I launch this job. Or if I go back a little bit and look at templates, let me filter back with a workflow template. There is a rocket sign, so you can launch this template from here. I'll go back to my template and launch the job from the launch button. And once I launch it, I'll pre-present it with this visualizer. So actually, there are multiple ways to launch your workflow templates or your job template. One of the way, as we saw now, and another important way to launch your template is through something called service catalog. So we have a service catalog functionality in the platform. You can have end users come in the Ansible service catalog UI. It's a separate end user oriented UI, and order from there, from the list, whatever automation, whatever something that they want to consume. This experience simplifies the interactions for end users. So you give access to the end users to access the service catalog, not the Ansible automation platform or to the controller. So for instance, the operation team and system team manage the controller, and they don't want to give the developer or a regular user access to the controller. They give them access to the service catalog, and from there, based on their rollback as well, they order or they can consume the catalog service. And that's part of the subscription for the AAP. And again, this subscription is available for the FAA folks through the ESP license agreement with Red Hat. So another way also you can consume automation is through API call from tools like Jenkins, or you can also respond to events we introduced recently, Ansible event-driven, so you can integrate the platform with Kafka, a monitoring tool, and responding to events that are happening there, such as an alarm or a message received to your Kafka pipeline. Or you can order automation from ServiceNow as a catalog item. So from the catalog item, you can launch some automation jobs. So let's go back and look at this template, and we're seeing here we're progressing with things. If you look at here, we created the infrastructure in AWS and the infrastructure in Azure while I was talking. So I created the entire landing zone on both cloud, and now I'm in the step to create my VMs as well. So 2 VMs were created, and we are in the other VMs creation. So I'm going to navigate to the job that we have, and look, we are now in the job view. And from this job, if you see all the details that you want, when this job started, when this job finished, which inventory that we work on this job, who's launched this job, it's an admin, or which execution environment used to run this job. So let me show you the output in here. And within, you can look at this output in the output sheet. You'll see the changes. If you look in here, I'm just gonna try to, yeah. If you look in here, you'll see the changes. So anything that says changes like this uh, means the actual state of the target system differs from the requested state. For example, we're creating a VPC. We're creating security groups and subnet in this case. Look in here, all of those were changed because there it was a green field. We did not have them. So before you know it, we create the actual VM or multiple instances, which happens in the next stage. So this is the first stage that we done. We created the landing zone. So these things, they change, which means like a change rather just validating or saying it's okay. Likewise, we can always come in and rerun these jobs and nothing would happen or nothing would change. Why? Because it's already applied there. Because if you look in here, your VPC was created. If I rerun this job again, nothing will happen because my VPC already created. So I'm not duplicating my job. Another important point. Uh, I want to bring you to this point. It's really like in automation, you can only focus on the end state. What you want is the end state to be, rather than the actual state of the target system, the actual steps like installing something or uninstalling something. That's the only key aspect of Ansible framework is to focus on the end states rather than the steps that would you take you to this end state. So all of those steps happening in behind the scenes and they're consistent. So if you run this on multiple environment, multiple green fields, they'll run the same in the same way. So I'm pretty sure there are no change, nothing different. It's not like a procedure that an end user apply it manually. Probably we do mistakes, right? So probably I configure this VM different than the other VM because uh, I'm not consistent or I applied something differently. I thought that would work for me, but uh, the other way it didn't. So let me go back into the job view and let and see in here. If you look at here, we see as we speak, we see jobs are running and jobs historically in the past with all the details when they were ran, when they who ran them. So I'm going to create on a specific job. Let's say I'm going to create on a create VM. So create, I have this one, create. And as I mentioned, you can drill into everything in here. What time this job started, or who launched this job to the admin, and what time it finished. And also you see the project details, the the repo that this job was launched from. So, and you'll see multiple version. What version is this job uh, running from? Like any software project, it's like we think now as automations becomes like a software development project where you would define your automation inside a Git repo. You would plug your Git repo via project into the Ansible automation platform control and start consuming things from there. So if we look in here, let me find mm, my repo, my project. Here I have this job was launched from this project called Ansible official demo project. And if I dig into the details of this project, I'll see the source control URL, my GitHub repo, and I'll see which branches that ran into this job. So there's multiple branches within this URL. Let's send here. And I see in here, I have multiple folders. There are some folders for Azure, Cloud, or your Linux, or if I go to the Windows, and within the Windows, I have YAML file, the setup YAML file, that set up for me my Windows VM, or patch the VM for me. And from here, you can see all the details, all of your YAML. And those, and the beauty of the YAML file is that it is uh, a readable language by human. Anyone can read. So if you don't have experience and you try something to read something in the YAML, uh, you understand it yourself. It's not like a C and C++ language that needs developers and specific skills to develop and write. So everyone can write it and read it. And here you could see the details. If you try to read it through, you'll understand what's going on. And that's all of that, all my infrastructure are defined as a code, as a YAML file in here. I don't write modules. The modules and collections already there. Red Hat and the third-party vendors like Cisco, Dell, or whoever created them for me. So I don't need to worry about creating modules because these modules are certified and curated from the vendor who created the platform. For instance, if you're uh, deploying things on your firewall or on your Cisco firewall, Cisco created a module for your modules for your firewall, let's say changing a route or applying access list. All of those are there. So I'm going back to the platform. So now you'll be able to see multiple branches, as I mentioned. You're able to approve something on a source control repo, which then would be automatically invoking this new code before committing it into a main branch. So you can have full closed loop automation using this approach. This is a commonly referred as a GitOps, and it would be our next logical step to unlock significant value after automating individual domains using a unified platform approach. So I'll get back to my template and let's see where we are now. There are still jobs running. I'll go to the templates. Look at jobs. And from the jobs, I see where we at now. I created all the virtual machines, and now we're going to the next step, which is patching. So, uh, through these steps, and after the patching process completes, it will go at the actual deployment of your application. So, in terms of patching the process, you can think about a couple of aspects of patching here. There is OS patching that you could incorporate into this kind of a view, or you can have also OS patches applied directly to your OS images before creating the VM. So you create curated images like your AWS, AMI, Azure images or vSphere or something like a VMDK image or a template on a vSphere environment. And now we can look at the Azure example to see that too. So in this example, in the Azure example, you can have another pipeline. So I can have specific another pipeline in here where you can create the OS images to a specific schedule and create those AMI and OS images to the latest patches and harden them and hardened reapplied into the OS images on a certain cadence. So let's go through the patches job as well. Let's see what's going on there. So it's in here. This is the Linux patching job. It gives you in the details section, you'll see all the details. And in the output section, you'll see what's going on. What changes? You see in here, the changes applied to Node 1 and Node 2. I have two Linux machines that I'm trying to apply. And if you see the Node 1, it's already patched. So I do not have to run, let's say this command, use a pin Python, run the Python module, and then going to the patch process, scan the packages, scan the services, upgrade packages, and into the upgrade patches through YUM or DNF. I see that my node 2 was skipped. Then I go to the reboot process. After I apply the patches, the system will be removed automatically and will be up and running. You can plug in here a compliance check like state compliance check or CIS check. Here, go back. So let me get back to the top view as well. So in this view, we're not actually a rollback, right? There is no rollback. Still, you can add a rollback step here, meaning if the Windows patches is not successful, you can roll this back automatically and go back where you were before, which in this case is just a plain Windows installation because this is an end-to-end pipeline. I'm working incorporating with a greenfield. So it doesn't make sense to incorporate a rollback here because, yeah, as I said, we're dealing with this greenfield environment deployment. However, a rollback could simplify uh, or could simply by removing the previous the failed VM or alert you or notify the administrator to rerun the job or something like that. But yeah, and if in this case I'm working with a brownfield installation, you could add a step like for a rollback. It could be going to a snapshot installation package or whatever that might be. And one important things to know is that we need to select the system that we need to work with. And automation, if we look at the job, if we look at this job view, for example, for, for the patching detail, for the patching job, let me show I can patch. So I'm working with the, let me work with the Linux patching job. Go into details and look in here, we have something called workshop inventory. And this is particularly for this demo. So I'm going to navigate to the workshop inventory. And if you look in here, you'll have something called sources. And you'll see in this case, AWS inventory, Azure inventory, and Insight inventories. So this is very important because if you're dealing with a multiple instances, dealing with any large environments, you will have multiple different instances coming in and being provisioned from this environment and other providers. And for any given application, you're going to be using a particular set of instances versus other instances that might be already out there deployed for different applications or other reasons. All the while, your automation needs to perform the automation steps against the correct subsets or groups of instances, and all that enabled through the inventory capabilities. So we provide out-of-the-box inventory sources from multiple different cloud and virtualization providers, including VMware vCenter, or AWS, Google Cloud, Red Hat ITM, Red Hat Satellites, and others as well. So this is the idea here that you would actually plug in or select the drop down here, the source where it is in this case is AWS, and you would provide the credential to access. So what would happen is before it runs any automation. In our case, deploying and running Windows patching, and then finally deploying application, it will go ahead and ask the Azure provider for the actual instances running using the credential provided. This will provide consistency and ensure that you do not have the manual processes and steps to define your IP addresses or similar customization. So if we navigate through those steps, I'll see the groups, and I'll see the group names are automatically defined based on the tags that I attach to those instances. And of course, all this happens based on the standards you define in the Ansible automation playbooks. The Ansible automation playbooks that I showed you in here has all of these tags and all of these definitions. So if I'll look in here and go to the host group, and in the host group, I say, sorry, let's stay in the groups and go to the OS Windows group. And within the OS Windows, I'll look at host. And within the host, I see I have two virtual machines within my host. So I group them as a Windows group. So for instance, if you want to apply patches only on a specific group, only in the Windows group, you your inventory will map to this group. So it will not apply patches on your Linux group. So you have this kind of granularity to reach any server, any host, any group, or any organization that you want. So pressing on Windows and expanding this, what we've seen here, you'll see you have your host IP address, the actual creation date, the volume ID, and a bunch of other information that's actually very useful inside your animation. Right? Then we're looking, so all of these variables that will be available to your automation developers. And on top of that, you can generate any additional variables, facts during the execution of these jobs, making them available in Facts app. So you could pass these variables on air. So it is something flexible. And with that, you can also generate more insights within the automation environment. For instance, with patches are installed, when install patches, you could cache and generate even more insights, reports. So these reports can be sent to your operation team, it can be sent to the system team or application team that the application is ready or the environment is already patched. You'll see all the patches were installed. Uh, all the updates that happen. And this becomes a powerful feature when it comes down to understanding and executing automation, but also making that information available to any other tools out there via API. So anything that we have inside the inventory is available via API external, which gives visibility to environments that you interact with, like AWS and Azure. So what I'm gonna show here, actually, this demo, I'm going to navigate back to my jobs to see what happened. Going in here, jobs, and look at my workflow job. So look at this. How cute is this? So while we're talking, we through this demo in less than 40 minutes, we created an infrastructure on Azure and AWS, created 6 virtual machines. We patch these VMs and install applications on top of these VMs. So I'll move, I'll navigate back to to the console and see other tabs, what tabs that we have in here. So the jobs tabs where we run our jobs, the dashboards, it shows all the details that you need. Uh, the schedules, and the schedules, it's where you schedule jobs. For instance, you have a batch job that you want to run, or you have like a cleanup, authentication, and all of that happens in the background because they're scheduled. For instance, I have this schedule on June 20 to run this certain job, or I have some cron jobs like running jobs on daily or monthly basis. Activity stream, all of this, all the events that happened in the system on the Ansible automation platform w- are logged here. So, for instance, we created the Podman web server, and who created initiated by whom the system, and the user admin did that. So all of that it's logged here. And with workflow approvals. Approvals where our back can place some roles. For instance, you have an L2 engineer wants to start a workflow, but the admin or the manager has to approve this job. Where this approval process pops here and send a notification for the manager to start this uh, to approve this process. Another thing, access. And with access, where you can manage or you create your organization, users, team based on our back roles. So, for instance, I have my organization here, my default organization here, another organization. I can create different users. I have only one user, the admin, and those users I can give them uh, the access level that they need to access the system. For instance, I have a regular users with read access, certain projects, certain templates, not to all templates. I can execute mm, some other templates while he can read from other templates. Teams where you can group multiple you can group multiple users together. And in here, the administration tab where you can manage your controller, your Ansible automation and platform. So this is for the admin for the platform admin. And another thing that I want to show you is something called uh, Automation Hub. I'm gonna use the same login admin. And within the automation hub, you'll see here the collection. This is called a private automation hub. In Ansible Automation 2.0, we have two automation hubs. One is private and one is public. The public you'll find all the collections. So what I do here, I have some of these collections. These collections are curated, certified Ansible modules, Ansible collections, and roles. developed by the vendors, either Red Hat or third-party vendors like Microsoft, AWS, Splunk, whoever, and those are available to you. So if you want to automate job, you use these modules because um, they are they're out there for you. For instance, an example for a module: create an EC2 instance, DNF. It's a module. DNF. It's a module that you can pass parameters through Ansible to like install, update, delete. So all of those are defined and developed. So you don't need uh, to rebuild them or reinvent the wheel. All of that it's there for you. And if something happened, you contact Red Hat or you contact the vendor themselves directly. And one beautiful feature in Ansible automation platform, it's we're using something called execution environments. And within execution environments, you'll have everything that you need, the runtime that you need. For instance, I'm running Grill 8 as my Ansible on my controller, even though my execution environment running on version 9 because it runs as a podman control containers. You don't need to manage podman. You don't need to manage these controller containers. Mm, but everything is available to you. So we now will reduce the dependency. For instance, if you have a Python 2.9 on one of these execution environments, and you have an aware version of Python on the controller, and your application or your automation has to run on an older version, you can use this execution environment because it runs as a container and you limit your dependencies. So, I'll stop here and I'll do a quick recap of what we have seen. So, using a secure collections and content available within the platform, various teams now can bring their own automation playbooks, can create their own automation playbooks on board, and they can give access to other teams, use a push button deployment for line of business users or operation team, and you can also then create these powerful automation pipelines workflows to test automation end to end and validate the automation before promoting it to the next stage. And finally, you can give access to end users and users where they can not only consume automation within the platform as we have done here, but also they can come in ServiceNow, Jenkins, or other tools and consume automation from there the same way across all the domain as a catalog item or etc. All of that helps with standardize your automation across all the teams, eliminating any manual processes, loss of productivity, and security issues arising from lack of standardization or visibility. Which that will conclude my demo today, and thank you for listening. So I'll open it for questions, and I'm happy to answer any questions in the chat or in the Q&A section. I'll also going to drop my email in the chat. Probably some people they know me, so feel free to contact me, to email me if you have any questions or any concerns related to Ansible or any Red Hat related thing. Yeah, how does that apply to OpenShift? So OpenShift itself uh, built based on an Ansible. So within OpenShift, we have something called operator framework. And the engine behind this operator framework, Ansible. So within this operator framework, you can automate day one, day two activities for your operators. And your operators can be a database, like MySQL database or Postgres database. And you can automate day one tasks like provisioning this database and setting it up. You can automate day two activities like patching and upgrades and reporting activities. And that's applied to Red Hat stuff as well as third-party ISVs. OpenShift itself also built to be automated using Ansible. And also you can deploy Ansible as an OpenShift operator. So if you go to the operator hub within OpenShift and you said, all right, I need Ansible, everything is almost automated on OpenShift, but I need to use Ansible to automate stuff on AWS or uh, for my machine, for my virtual machines, or for my VMware infrastructure. I can deploy Ansible as an operator. That helps me to automate day one, day two tasks for Ansible. So all of these jobs, if you see it in here in the administration tab, in the Ansible automation platform, can be automated. So I automate the installation and I automate the patching or the upgrades for the Ansible platform. I hope that does answer your question. Any other questions? I just pasted my email in the chat. Yeah, please email me if you have anything, and I'm happy to answer. And after this session, I'm going to this session is recorded. I'm going to upload it to YouTube and make it available to you through the DLT portal, so it will persist there. So anytime you want to come and check it out, it will be there. I'll give it another minute for questions. If not, we can call it for today. All right. As we don't have any further questions, I would like to thank you for your attendance today and hopefully to see you soon in the next webinar. Thank you very much and have a great day.